is to interface a motor using relay with the Raspberry Pi and write a program to turn on the motor when the button is pressed. So you require the materials required for this experiment. You require a switch module, relay, the DC motor, regulated power supply, which we are using 12 volt instead of 5 volt. So the program is exactly same as experiment 1B. Experiment 1B, we had LED module, which was as well as switch module. So here the LED module is replaced by a relay, and the primary side of the relay is connected to the computer, and its secondary side is connected to the motor. So the program is pretty much similar. Experiment 1B, which is you have these things for setting the time, adding a delay, then you use a GPIO function or library available in Raspberry Pi package, set the warnings to false, use PCM mode, and you are using pin number 17 and pin number 18. So pin number 17, with the help of pull up register, we are connecting it to the switch module, and pin number 18 is given to the relay module. So relay module, this is a relay module which has got 3 pins in the primary side, which are VCC, ground and input. So earlier in the LED and switch experiment, the LED was connected to pin number 18 or GPIO 18. In this case, GPIO 18 is connected to the V-in terminal of relay. So VCC 5 volt supply has to be given to this relay. This is what it is, the structure, the relay module working. So you give a 5 volt supply here, plus and minus, and this is your input pin. S is your input pin. So as when you're sending a signal from the microcontroller to this relay module, this is gonna make the LED on. So as when the LED is on, the light gets incident on this photo transistor. So this photo transistor will be turned on. When it is turned on, then you are sending like 5 volt is given to this coil, and here you have a ground. So 5 volt is applied to this coil, which means the current flows through this coil, due to which this gets energized. You call there is a magnetic field effect here, due to which this switch, which is designed with the help of ion core, swaps to this position. So the common to NO, there is a permanent connection. That's what happens. So after once you make this primary connection, then the secondary connection for interfacing it to the motor goes something like this. The common terminal is connected to positive supply of the voltage regulator, through which you need to drive the motor. So plus 12 volt terminal is connected to common, and the ground terminal, the ground of the regulator, is given to the motor's one end. The motor's second end is given to NO terminal. So when this LED glows, so there is a current flowing through this coil. At that time, this mechanical switch will switch over to this position, in which case you have a 12 volt running through this line, which is given to the motor. The other end is given to the ground, which means the motor will start rotating. So for driving it, the motor is driven externally with the help of the voltage regulator. So basically, if you intend to drive a motor with the help of microcontroller, it's quite difficult, because the microcontroller, through the pins of a microcontroller, the current which can be sent through this terminal pins are very small. The rating is in terms of 16 microseconds. so which is quite very low, so you cannot trigger it. Even if you supply this to the motor, it might start rotating, but it will drive it with the RPM rating is very small. So that's the problem, why the reason why we use a relay and trigger the motor. Okay.